Thank you. My name's Ronan Daly, and I'm going to talk about polymer imprinting. So, I start? Yeah. Great. So, I work in CRANN and the School of Chemistry for John Boland, and what I'm going to talk about is the focus of my PhD thesis. And I've been making little bits of plastic for the last few years, and luckily when you look a bit closer, they're quite interesting. And in fact, they're made up of ordered structures of holes, like these ones, and you can see in the side view what they look like. They're quite aesthetic. And it's a self-organization technique. So why is this interesting? It's quite an exciting area, and it's mainly because it's not fully understood yet. It's not really a developed field. So hopefully we can give something and sort of give some sort of scientific understanding to this. Also, it's very fast and very cheap to make, so commercially it's quite interesting too, with a few of the suggested sort of uses in pharmaceutical devices. And the recipe is also very easy, and there's only 3 ingredients. We've got a polymer, which is a very long chain of molecules stuck together. In this case, polystyrene, which you're probably used to seeing in packing material, or a lot of the people here see it in Petri dishes. And then have a solvent, so something we have to dissolve the polymer. And then finally, water vapor, and that's it. So we also need to make use of evaporation. So as I'm standing here sweating in front of you all, the water on my skin is evaporating off, cooling me down a little bit. Not much, I'm more like him. And then we take advantage of that as the solvent evaporates and cools down. And we also need to use condensation, so the humidity in the air hits something cold, turns into liquid. So that's everything. That's all you need. So you get all that solution, you put it on something relatively flat, and hopefully I haven't gone too far now with this, sorry. And it's not working. Okay. So as it evaporates, it cools down. The water droplets start to pack, they move around. You can see them there under a microscope. They've condensed down because this solvent is so cold. And once they've packed, the evaporation continues, and all you're left with at the end is the polymer. The solvent is all left, and it traps, it imprints around the water droplets. And what I've been doing for the last few years is trying to understand the interaction of the water droplets, the physics and the chemistry behind it, all the different, only 3 ingredients, but what they do, and what all the other parameters around this do as well. And we want to be able to use that and tune it to make different structures of pores. So we want to, and what I've been doing really, is controlling this process so we can tune it towards the different applications that I mentioned. And that's everything. I hope I'm within the 3 minutes. Thank you very much for listening.